Eularian and Semi-Eularian graphs. So some graphs have a trick to them, where you can create a trail where you travel every edge but never repeat an edge. If you can start and finish at the same point, it is called a closed trail. And it's an Eularian graph. So for example, if I start here, I can go along here, and then here, and then here, and then here, then here, then here, then here, and I'm back where I started. I travelled every single edge, but I only travelled it once, and I covered all the edges on the graph. So that is an Eularian graph. If you start and finish at a different spot, on the other hand, it's called an open trail, and it's a semi-Eularian graph. So if I start here, I can go here, 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 and back down again. All the edges are covered. I only travelled every edge once, but I started here and I finished here. So it's semi-Eularian. The good news is there is a trick to seeing if a graph is a Eularian or a semi-Eularian graph. At each vertex, count the number of edges connecting. If all the vertices are even, then you have an Eularian graph. And you can start wherever you like, and you'll always end up back where you started. So, at each vertex, count the number of edges that connect, and that will tell you. If there are two that are odd, and for example, there's an odd one, there's an odd one, and the rest are even, you have a semi-Eularian graph. If what you then do is you start at one odd number and you finish at the other odd number. If there's more than two odd, then it's just a graph and there's no trick. You can't cover all the edges without doubling back. So that is Eularian and semi-Eularian graphs.